we have the equation y to the double prime plus 2ay prime plus the quantity of a squared minus b squared times y is equals to f of x. So for finding the complementary solution, we let y is equals to e raised to mx. So y prime is equals to m e raised to mx, and double prime is equals to m squared e raised to mx. So substituting this to the general equation, we have m squared e raised to mx plus 2a times m times e raised to mx plus a squared minus b squared times e raised to mx is equals to, we equate this to 0. So we factor out e raised to mx, so we have m squared plus 2a times m plus the quantity of a squared minus b squared is equals to 0. Dividing both sides by e raised to mx, so we have m squared plus 2a times m plus quantity of a squared minus b squared is equals to 0. To find the roots of this equation, we have to use the quadratic formula, which is m is equals to negative 2a plus and minus the square root of 2a squared, which is 4a squared, minus 4 times a times square root quantity of a squared minus b squared, all over 2 times a. So we have negative 2a plus and minus the square root of 4a squared minus 4a squared plus 4b squared, all over 2. So we cancel 4a squared, so we are left, so the roots would be negative a plus and minus b. Now these are two distinct roots, so we are considering case 1. So our complementary solution would be C1 e raised to negative a plus b times x plus C2 times e raised to negative a minus b times x. Solving for yp, or the particular solution, we considered this as our y1 and this as our y2. So y1 is equals to e raised to negative a plus b times x, and our y1 prime is equals to negative a plus b times e raised to negative a plus b times x, and our y2 is equals to e times negative a minus b times x, and y2 prime is equals to negative a minus b times e raised to negative a minus b times x. So first we get the Wronskian, so that would be y1, which is e negative a plus b times x, and y2 e negative a minus b times x, y1 prime e negative a plus b x times negative a plus b times e negative a minus b x times negative a minus b. So solving this further, we will get a Wronskian of negative 2b e raised to negative 2ax. So solving for our w1, we have we let y1 to 0 and y1 prime to be f of x. So y2 is e raised to negative a minus b times x, and e negative a minus b times x times negative a minus b. So w1 would be equal to negative e to the negative ax minus bx times f of x. W2 would be equal to, now we let 0 the for y2 and f of x for y2 prime. So we have e to the negative a plus b times x and e to negative a plus b times x times negative a plus b. So further computations, we get e raised to negative ax plus bx times f of x. Now, we have the u1 prime is equals to w1 over w, and it is equals to negative e raised to negative ax minus bx times f of x all over negative 2b times e raised to negative 2ax. So for u1, we integrate both sides, so we have 1 over 2b times e raised to ax minus bx times f of x dx. Solving for w2, so first w2 prime is equals to w2 over the Wronskian is equals to, so we integrate both sides, e raised to negative ax plus bx over negative 2b e negative 2ax times f of x. So u2 is equals to negative 1 over 2b times e raised to ax plus bx times f of x dx. So now for yp is equals to u1 times y1 plus u2 times y2. So y particular is equals to 1 over 2b times e raised to negative ax plus bx times the integral of e raised to ax minus bx times f of x times dx minus 1 over 2b times e raised to negative ax minus bx times the integral. By the way, this one is plus and this one is minus, so moving on, we have the integral of e raised to ax. So again, this one is negative and this one is ax plus bx times f of x times dx. So further simplification, we have yp is equals to 1 over 2b times e to the negative ax plus bx times the integral of e raised to ax minus bx times f of x dx minus e raised to negative ax minus bx times the integral of e raised to ax plus bx times f of x dx. For the general solution, y is equals to y complementary plus y particular. So we have c1 times e raised to negative a plus b times x plus c2 e raised to negative a minus b times x plus 1 over 2b times e raised to negative a x plus bx times the integral of e times e raised to ax minus bx times f of x dx minus e raised to negative ax plus bx minus times the integral of e raised to ax plus bx f of x dx. So this is the general solution.